Good evening. My name is Isaac Opio, and I will be a little bit brief and straightforward to the point. Here is my presentation, and shall be presenting. I am presenting about an intelligent graphic visual stimulator for optimizing feed formulations. So here, the goal was to come up with a multi-output regression approach, or to develop a model that is going to be helpful for feed formulation. And so far in our work, we have been able to implement some models that predict energy nutrients. So looking at the abstract, just to peruse through, feed formulation is crucial in poultry nutrition and it influences overall health and productivity of birds. But then in this paper we propose a deep learning multi-output regression model to predict key nutrients in what poultry feed formulations based on their percentage composition. So we shall be demonstrating how the model is able to accurately predict nutrient levels, offering a computational solution to some of the challenges in graphics and the computing field. So in this work, we trained 5 learning models and we made the study propose their performance on what our data sets. Next. So looking at the introduction, sorry for that. Abstract. The keywords we have deep learning, machine learning, feed formulation, poultry nutrition, multi-output, regression. Those are some of the keywords in this work. So an introduction, you find that poultry formulation plays a crucial role in ensuring what growth of poultry, but the challenge lies in accurately predicting nutrient composition. For example, the nutrients of metabolizable energy, crude protein, lysine, methionine, calcium, phosphorus. So traditional methods like linear regression usually fail to capture what? Non-linear relationships. So looking at based on the previous literature reviews, you find that they talked about those traditional methods that could not analyze the intricate interactions between the components. You know, those solver-based techniques in software were not fully adopted in practical teaching, and a lot of challenges. So what is the problem statement in this point? Here we're looking at the traditional methods do not account for non-linear interactions between ingredients, leading to suboptimal formulations. And what is the objective? Here, our objective is to develop a deep learning model to predict multiple nutrients simultaneously and improve feed formulation accuracy. So, what is the computational problem? Here, to be specific, the research is addressing the ability to predict the nutrient composition in poultry feed formulations using deep learning based multi-output regression models. And by applying those advanced graphical visualizations to predict models, this research can make the invisible nutrient levels visible, offering nutritionists an intuitive, real-time understanding of how different ingredient compositions affect outcomes. So some of the challenges before then were the nonlinear interactions, the multi-output regression, the simultaneous prediction of multiple nutrients with interwhat dependencies. It's something a little bit complicated. Then the data visualization, it was not easy to make sense out of the data. But when you work on the visualization, the impact would be that it would improve feed formulation, enhancing sustainability and poultry performance while advancing precision not agriculture. So what is the proposed solution? The core components are to come up with a deep learning multi-based output regression model with a lot of layers and leverages the rectified linear unit activation and Adam optimizer to make sure that the model performs to its best. We also have heat maps and contour plots that help us to show nutrient gradients in feed formulations. Contributions to the computer graphics industry, real-time visualization. You know that interactive framework will be available for exploring the nonlinear relationships between feed ingredients. Then there was, of course, multi-output regression visualization to help us visualize the interdependencies between multiple nutrients. Then cross-domain application. Of course, this is going to extend into the engineering what it is going to extend the engineering graphics into the agricultural what industry. So what is the visualization of the tool's workflow, or like something like the methodology, we shall have data that will be fed into the model for pre-processing, of course. Then through model development, the various architectures and sections that the model will be designed with. And after that, the model carries out, data splitting, employs the loss functions and all that. Then we shall be able to evaluate the model to see its performance. Then we hope to have a visual output, or when the implementation, when you advance from the model, you should be able to visualize outputs of the model so that farmers can be able to what? To see the outputs of their results. This is still explaining the methodology. I've already run out of 5 minutes, but we have data collection, data processing, model development, and all that. EDA results, we have got a data summary that talks about the input features, distribution analysis, where histograms reveal some of the features concerning how widespread the what most of those ingredients were onto the data sheets. Then we have got correlation insights through the correlation what matrices. So you can look at this one. This was an insight on the layer diet model that showed some strong correlations between some of the feed ingredients and the target variables that we wanted to target. We also have a correlation matrix for the layer chicks. We also have a correlation for the grower, then also a correlation matrix for the starter. These are all for the various data sets or the various models that we wanted to train. Then also we have one for the broiler finisher. Then the graphical results of the models. This one is trying to show for the broiler finisher model results. It's trying to show us that yes, after the model was trained, you can look at the level of accuracy. The straight line shows the actual values, the actual what? The line of best fit. Then the dotted spots are trying to show the predicted what? Values, or how our model is performing. So you can see the results. It's not really accurate, but it's somehow very okay. And this is just a graphical representation of the predicted results. It's just like a graph that can show you, you know, the level of prediction of the nutrients based on what? On integer values. Same thing for the broiler starter results. Then these are the graphical predicted format. The layer dietary results, the predicted nutrient levels also represented graphically. Then the layer grower models, also showing the line of best fit and predicted what? Values. This is the graphical representation. The layer chicks model also we have a representation for that. Then the predicted nutrient levels. This is the graphical one. Now, application of the tool in real world scenarios, you find that the model is predicting different levels of each feed ingredient from various feed formulations that the farmer could mix. Now, the nutrient with the dominant presence together with varying peak values of other nutrients can graphically be represented. Then farmers can actually use that information or take advantage of infographics to be able to visualize the feed formulations. Thank you so much, and I believe I've tried to work on time.